Welcome back, everyone. It is my privilege and honor to introduce to you, debuting his first lecture for the Menger Institute and Menger Academy on epistemology, our very own director of the program, Ethan Akimoto. Thank you.
All right, so this lecture is on epistemology. It's a big word. You've heard it yesterday. It's come up here and there. But we're going to go deeper, not just in economics. We're going to go into the real truth of what epistemology is, and you'll see that not only does it underpin real economics, it's the basis for understanding what's true and false in every single field, everywhere in your life, including practical decisions. So epistemology, big word, comes from the Greek episteme, which means knowledge or understanding, and logos, like in biology, sort of reason, study, science. So it's the study of knowledge. So it deals with philosophical questions of how do we know what we know? What is knowledge in the first place? And what are we doing when we're doing science? So there's three parts to this. I'm going to show you epistemology and good epistemology versus bad epistemology. And from that basis, from that foundation, we're going to narrow it a little bit to talk about Austrian economics, its epistemology, and why Menger actually had it right. And the empiricists, who he spent a lot of his time arguing against, why they're wrong. And why that method is not only wrong in economics, it's also wrong in every single science. And finally, I'll conclude by taking out some popular mathematical methods that people use in economics and beyond. I'll show you why they're wrong and how they've stayed relevant because their users are just hiding behind math, which it seems fancy, other people don't understand, they get intimidated, but it's really at its core, it's completely wrong. So knowledge, broadly, is information, and it's a particular kind of information. It solves a problem, and that might trigger something in you where you notice that it's teleological. So it's relevant to things that have a problem to solve, like an organism, a human being. It's a particular set of information that tells you why something happens the way it does, and it allows you, through its use, to get somewhere you want to go, to do something you want to do. And it's very specific. It's not random. It exploits some kind of regularity in reality that's universal. Like, for example, in our genes, there's knowledge. Like our legs, why are they here? They're here because they get the knowledge of how to produce legs is embedded in our genes because it solves the problem for the organism. It allows us to walk, to move efficiently, to get food, to travel out of dangerous areas. We have the genetic knowledge for eyes because seeing food's important, recognizing people, recognizing faces. It's very important for survival, for navigating. And in the physical realm, it's like knowledge doesn't have to be written down or verbal. It can be embedded in things like chairs. Like chairs, why is a chair structured the way it is? There's an explanation because there's knowledge, because it can get tiring to be standing all the time. So we use the fact that like physics, we balance the weight across multiple chair legs, and there's a back to hold up our back straight. And that knowledge embedded in the structure of the chair solves our problem. It gives us a place to sit, to relax. Same thing with wheels. we understand some principles about how, oh, well, you get something spinning one time, it's easy to keep spinning. There's little friction when it's rolling on the road, so it's an efficient way to travel. And that knowledge, someone can get it by interpreting what they see in the wheel, not even having to read a book. And same thing with buildings. Why is there plants at the front door? Why is there a kitchen in the house? It's because when you're building the house, you know that people want to cook food. You want a nice entranceway so people feel welcome. And even in our cultural knowledge, there's manners that we're told, and they're not just arbitrary. They come from knowledge of human psychology, right? You say thank you when someone gives you food, not necessarily just because someone told you to do it. If you think about it, when you say thank you, you're signaling gratitude. It makes the other person more likely to help you out again. It solves problems. It 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 creates group cohesion. And yes, so beyond just spoken word or writing or most objects, it can be in this knowledge can be in genes, in books, computers. It can be transferred between one and another. And it's even embedded in our cultural stories and sayings as wisdom. It may not be obvious immediately, but they can be implied. So in more depth and getting more relevant to science and scientific theories, knowledge is based on explanation. It just doesn't tell you that something happens. It tells you why something happens. There's a mechanism. Like how, for example, in the chair example, I used that the backing of the chair, it's there because it holds up our back so that it helps us sit up straight with less effort. And it's not given to us. We don't, quote unquote, read from nature or just get it handed to us. We have to interpret, and then creatively we come up with this knowledge. It's a creative process. Conjecture is another word for trial, as in trial and error, or like a guess and check. So when you conjecture, you come up with a new idea, and then to determine if it's a good explanation, you're going to take it as true. You test it, you criticize it, and that can be out in the world experimentally, but also through thought experiment. So truth is the explanation that best survives criticism. And there's a parallel here to even genes and evolution. When the genes mutate, that's a conjecture of a new sequence, a new kind of organism, and then it's criticized by the environment, and the ones that survive end up continuing to replicate. And there's a relationship here with data and empiricism that's very key, that we create our theory to explain our observations, our data. We look at something and then we come up with a reason for why the way it is. Like if I see something bright, it doesn't tell me that it's sunny. I have to think, am I inside? Oh, it may be a light bulb. Am I outside? Oh, maybe it's the sun. So, so our theory is always guessed. It's created in our mind. And data cannot give you theory. It just plots in a chart. When people say they got a theory from their data, what they're really doing is interpreting what's on the chart, which could be arbitrary, and then they come up with some explanation for the data. It goes backwards. And even in everyday life, when I'm speaking, we can always be misunderstood because you're observing, you're sensing, you're hearing what I'm saying, but it's up to you to take that, to interpret it, and extract the understanding yourself. So you can always be misunderstood. And it's not when we speak, when we teach, we're always error prone because we cannot perfectly transmit what we're trying to say. So explanations, they tell you why something happens, they're about mechanisms, they're created in your mind, but we need to narrow them down. I can give pretty bad explanations. I can say, oh, if you have a cold, just eat this grass because the grass is going to fill your tummy and you'll feel better. It's not a good explanation because I didn't tell you how much grass to eat, why to eat grass over something else. So through those types of specifications here, if I'm not telling you the cause of what chemical in grass will make you feel better, the mechanism, how the chemicals work, and if it's limited, like I didn't tell you 1 cup of grass, 2 cups of grass, that's criteria for you to know that I'm BSing you. So they're hard to vary. The components can't be easily changed without losing explanatory power. So every aspect of a good explanation is crucial. You have the amount of a medicine you take is important. The kind of chemical in the medicine is important. When to take it is important. It's not arbitrary or easily changed. I'll tell you, like, you need 1 cup of Tylenol at 8 a.m. because the active ingredient is going to ameliorate some pain receptor in your brain. So a good explanation, we're never certain. We can never be certain subjectively that we found the final truth. There might be final truth out there, but subjectively, we'll never know. What we take as true is just what has survived our criticism the best so far. It's our best theory. We take our best theory to be true. That's how we have to operate. We can never know for certain. So and people think science is about prediction. It's like, oh, you get a theory, then I can predict the future. Not necessarily. That's not the aim in itself. The aim is explanation. And from that explanation of how things work in the world, then from that is how you produce your prediction. If I tell you it's going to rain tomorrow, it's going to rain next week, I can't just, it's not a good idea just to believe me because I'm making a prediction. I have to tell you why. So there are different methods of choosing what to believe throughout history. I mean, these are all still here today, but one of the oldest is dogmatism, or from doctrine from some authority, from your ancestor. It's just told you that to do something without an explanation, and you can't ever challenge it. For example, this is I can say, well, my ancestors told me, eat red berries, don't eat blueberries, and you can never challenge it. They haven't told me why. I can't challenge it. Maybe I move to a new environment and the red berries are poisonous, the blueberries are edible. So you start to fall into error that you can't fix if you subscribe to an epistemology like dogmatism. So science really took off when we had a improvement in some sense to epistemology, from just believing authority, believing what you're told, to empiricism. In the Renaissance, had growths in physics and biology, because people started to say, oh, I'm not just gonna believe what I'm told. I'm gonna observe the world and then think for myself. Does this what people are telling me, does it align with my own experience? And that's an improvement in the sense that if there's an idea that's no longer holds or it's wrong, you can revise it, you can fix it, you can do trial and error correction. Where it fails though is because it's not explanatory. They're not involving mechanism. They're just saying, oh, I perceive it this way X amount of times in the past, so it's going to be more true. For example, the sun rose every day that I was alive, so I know the sun is going to rise tomorrow. That doesn't tell you about any other mechanisms that can interfere with that. You could say, oh, in late August, it's always sunny in the past, so it's going to be sunny tomorrow. But without telling you an explanation, there's a chance that, oh, maybe it could be rainy, even though most days it's sunny. And actually, there's a test you can give to any empiricist you encounter. It's called, so you jab, and then you fake like you're going to punch their head again, and then you hit them in the stomach. Professor Georgie, can you? I'll be the empiricist. So he's a smart one. He's gonna jab to my head. I'm gonna flinch or maybe get hit. After a couple of times, empirically, I'm gonna say, oh, when he starts to move like this, he's going to jab to my head. So he's gonna do that again. But this time you can feint, yeah, and do something else. Or maybe go to my body when I block. Yeah. So the empiricist is going to get hit, but a smart boxer who understands what I'm saying is going to feint because he knows that people genetically we have a genetic reflex to protect our eyes, protect our face. We're going to move our arms to move away. And he can exploit that by faking to the head and then hitting me in my stomach. Another example of an empiricist would be a stupid chicken who's in a farm. The chicken's going to wake up every day and say, wow, this farmer, he's feeding me. I love this guy. He's my friend. He can go for 10 days, 100 days. Empirically, I'm going to get more and more confident in this theory that the farmer is my friend. Even if somebody else warns me, so they can say, well, for my direct experience, the farmer only does nice things for me until one day the farmer breaks his neck. So that's why we need to move beyond empiricism to what we call critical rationalism, which is the epistemology I've been talking about we need to create explanations and we refine them by criticizing all the competitors until we're left with our best one, and that's our truth. So taking this broad picture into Austrian economics, our founder here, Karl Menger, a lot of his work beyond his principles book, which was general ideas about economics, his other works on investigating the methods of the social sciences, where he spends a good amount of his life and his career fighting these people who are ridiculing his approach to economics from the German historical school. And historical as in the sense that they're empirical. They're looking to history. They're saying, oh, we just look at historical data, what happened in this country at this day, and then we know what's going to happen in the future from that. Menger was completely against that. And he knew that our real scientific knowledge is going to come from explanation. So he's not reading from data. He might have looked at data, but in his mind, he created the explanation for it. So what he does is explain our choices through the implications of specific causes. Very narrow. You can't easily deviate, multiply it by 2, multiply it by 3, and have it work. It's logical. So these are the axioms. And from it, him and his student Mises, they developed what we know as Austrian economics, praxeology, and the other topics we've been covering. So he knew that history and data aggregation are completely inadequate. So he was writing about economics and social sciences But now we know that he had the right method for all of science and all of knowledge. So given that we have Austrian economics, we have the critical rational epistemology, we're going to gladly take out some 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 mistaken methods that people like to use in economics and science and in popular articles. A lot of them have to do with mathematization, they're explanationless, and we'll see why they crumble. So economists of the mainstream school, even in some hard sciences, are very familiar with regressions. So you take some data here, little dots on the screen, and you, with a formula, a given formula, you generate a curve. So the most common, the first one that people are taught, it's the simplest, it's called a linear regression. You make a straight line that minimizes the distance from these points, and from the slope of the line, is it going up, is it going down? You're supposedly able to tell the relationship between one variable and another, and supposedly you're supposed to be able to predict the future from that. Just because the math said so, the math doesn't lie, quote unquote. Completely not the case. Because when you understand more mathematics even, you'll see that you can, with the same exact data points, you can fit another curve to it. In the middle here, we have the quadratic function. You say, oh, well, as we move along, we move to the right, the line goes up and up and up, and it goes down. This could maybe be more like, oh, with exercise, you benefit more, and then after there's a point of diminishing return, rather than on the left being having more exercise, be healthier, often to infinity. But then you can even come up with completely wacky curves that supposedly perfectly fit your data, like this polynomial function on the right. And there are infinite numbers of them, literally infinite. And you can use this to justify whatever you want to justify. And this whole time, I haven't told you a single explanation of why I should use one curve over the other. So this is a little more technical technique called Bayesianism. It's used a lot in some of these Silicon Valley circles, effective altruism. There's they're saying that through this Bayes theorem here, it's a mathematical equation where you're using probability. So the essential idea is based on events in the past, I'm going to arrange my thinking about what's going to happen in the future. That's pretty much what this is saying. And as we know, it's empirical, it's inductive, it's false. So how this would work would be that on the left here, we have our prior beliefs, my confidence that something is going to happen in the red. Say it could be, I don't know, the stock market going up 5% in the next year. Our evidence could be, so I could make this prediction at the beginning of the year on the left here in the red. The year goes by, and our evidence was much higher now in the black. It can be that, oh, the stock market went up 10%. So based on that, according to Bayesianism, we need to update our probabilities of our beliefs and increase our new prediction in the blue to say, I don't know, 7.5%, 8%, without an explanation again this whole time. And similarly, people also say that I've I'm 50% confident that this will happen. I'm 75% confident this will happen. But it's a mistake to use these percentages, these probabilities. You didn't look into all the alternate futures and count 50% of them being one way or the other. It's just an arbitrary guess. Why 50%? Why not 51%? If you had an explanation, you would say precisely, this is going to happen or not going to happen. Matthew's not 50% wearing a black shirt. He either is wearing a black shirt or not, based on what my idea of how my vision works. It looks very, very dark, so I'm going to say it's black. And finally, we have game theory. This is another popular technique that people like to use. They like to seem, oh, this is so scientific. Look at all this math we're using. Stupid. So we have an example here. We have a two-player game. You've probably heard of the prisoner's dilemma. So we have two players playing the game here. Person one is represented by the first number or the left side. Person two is going to be the right number and the top. So they're two prisoners. They're both arrested and they're being interrogated. They have choices here. They can C, confess, or D, defect or and be silent. Or deny, sorry, that's a better word. Yeah, don't confess. If they both confess, both of them get 3 years of prison. If one confesses, but the other doesn't, the one who confesses goes out free. The one who denies gets 5 years in prison, which is a worse outcome for that person, supposedly. But if they both are silent and there's nothing against them, they both get out with 1 year of jail each. So the game theorists would analyze the costs and benefits of moving from one square or another. You say that, oh, well, each player from denying, if they confess, that person is going to reduce their jail time, and they don't care about the other person's jail time going up. So they're going to not confess, they're going to deny. So then the equilibrium outcome is going to be that both deny because they're both acting in their self-interest. And the end result is both prisoners getting 3 years each instead of the 1 year each that they could have had from both denying. Supposedly that's how it works in the real world. But really it doesn't. So in the first place, we don't know that prison time to one person is the same as prison time to another. A person who's been to prison a few times, has buddies in there, knows how the system works. 5 years might not be as bad as 5 years for somebody who is, say, maybe physically weaker. They have no experience in prison. So our objective utility here that we're trying to calculate and the value to each person, it doesn't account for the fact that value is subjective, which we know as a basis for economics and human decision making. And it's also a closed game. It assumes people aren't creative. As in, like the example with the general possibly shooting defectors to keep everyone in line. People can arrange things beforehand. If I know I can deny to reduce my prison time, but if I do so, even though I have 0 years in jail, I know that my accomplice has cousins, has other gang members out there. They're going to come and get me. So that would actually be a worse outcome for me. So in the real world, these games, they end up expanding. And again, the model just completely falls apart. And there can also be other, just like gang rules. We can also know that, oh, well, we have our shared history. I don't know, our families are intertwined. We want to go out and commit crimes again, then we may just extend the hand and deny to confess, and both get out with 1 year of jail each, even though game theory would predict that we're both going to confess. So that's why these three very popular mathematical techniques, we can do away with them when you understand epistemology, because they're explanationless, they don't account for human creativity, subjectivity, and that when we truth is binary, it's not probabilistic, because when you have an explanation, it just tells you one way that a thing is. It's not 50% true, 30% true, or anything like that. Here's a summary. Any more questions? Yeah.
I have a question. Uh, it seems like in the way that civilization is evolving, in regards to people's psychologies, this idea of dogmatism, or the appeal to authority, that this scientist said this, therefore it must be true. Um, I don't know. Do you think it? I guess my question is, why do you think? Is it is it psychology? Is it propaganda? Is it ideas that people still revert to dogmatism or the fallacy of the appeal to authority or even empiricism?
A lot of times they don't know how knowledge works. Sometimes it's also convenient to be lazy. Sometimes it's not necessarily. If you have an explanation of why the person you're listening to might know about the subject well enough and you're not going to expend the mental effort, it's not worth it to you, then you could just take what they say. But really at the heart of it, it's not a it's not the way you want to be going throughout the world. It's maybe a false shortcut for convenience. Like saying when we're arranging the furniture in this room, it's fine to say the earth is flat. But at the real heart of things, if we're trying to predict things into the future, we're trying to make new technologies, make progress, we need to know that, okay, the earth is round, there's gravity, we need satellites to orbit somehow.
Mhm. Thank you. I have another question. Uh, Rothbard was talking about economics in a lecture, and he mentioned Carl Menger Jr., who I'm not familiar with, but Carl Menger Jr. mentioned that a lot of the times people think the quantitative economics versus the literary economics is more elegant or scientific because it has graphs, but then Carl Menger Jr. is saying no, 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 it's actually more elegant and true with literary economics because the quantitative economics has to necessarily um, uh, be it can't contain all the information of all possible choices, like the graph, right? I don't know what the point I'm making. What do you think of this idea that like yeah like choices when it's graphically demonstrated has to um necessarily not include all possible choices, whereas with literary economics, in a way, you can. It's more like more scientific. I guess that was the lecture, but I just want to hear what you think about
Oh, so can you
um
summarize?
this idea that quantitative economics is somehow more scientific than qualitative or literary economics. Uh,
I mean, it's not necessarily more scientific.
right.
We're just dealing with what's what's true, what's the best explanation of what we see. If there's a certain quantity we're saying, there's a specific, like we're using quantities to say show comparative advantage. We can use that. There's nothing inherently bad about using quantitative methods, but it's about how you use the math, right? Because with the with like a derivation, using the numbers to prove things, that's completely fine. Using logical deduction, you're not using induction, statistics, and past observation.
Yeah, so like I have a question, and like the question is, so like for example, if we were talking about the inflation, like we could say, okay, so inflation is because we inflate the money supply. And so we could say if we at this moment just print more money, that will cause inflation, and that is something you get from like that's an explanation you get like from your analysis from a retro perspective. But I think most of the people will still want, okay, we will cut inflation. Okay, I know if we inflate the money supply, we will cut inflation, but we want to know how much, or we want to know in what like range. So like my question is, how do we uh, use this type of like getting the like the explanation, but still getting a quantitative analysis? Because at the like we could still say that for example in that case both on the prisoner's dilemma, no, the prisoner, both of the prisoner can like they are going to confess. Okay, but that's not like so quantitative. We'll still want to know like in how much amount, regardless of like the analysis we use. My question is how we can like still use like a qualitative analysis by some kind also get a quantitative analysis because we like kind of need like to I will say like measure the like the yeah the team like accountability.
So it's going back to the inflation. Like, yes, we know from our explanations that, okay, we increase the money supply. So there's the Cantillon effect. There's going to be generally prices are going to increase, but we don't have the explanation in that theory to say exactly what amount. And we can't actually know what amount. Maybe other factors come into play. That are beyond economics, like a certain, I don't know, there's disease on the orange trees, so there's less oranges, so the prices go up. Maybe somebody makes a new invention that changes the prices of things. So that's going to involve explanations from fields beyond economics. And some of them, they're just not knowable. And and if you're being truthful, you should just say we don't know. And as far as the prisoner's dilemma, so you're saying that, oh, maybe there's like a certain number to where they might confess if
Yeah,
I change the numbers higher or lower.
yes, maybe like a range of like confession. So like I'm not talking about like of using a quantitative analysis like it is like a quantitative way in the analysis, a quantitative result. Like
Well, they've actually done experiments with game theory from some of the originators. They've won their Nobel Prizes, and they found it very peculiar. They did this out in Santa Monica. There, they found that the people playing these games choose to cooperate in reality much more often than their math would predict, and they couldn't figure it out. And if you would say that, oh well, if you make the prison time higher or lower, that's going to necessarily change what people do. not necessarily the case because value is subjective to the individual's plane. So different people are going to have different numbers to where they're going to make one choice or the other. It's not universal. Depends on that specific context.
Well, we have a question in our chat.
So I joined it late, and thank you for the presentation. It was really enlightening. I was wondering about game theory. I mean, I was not a major in economics, so I was not so sure like how the game theory can apply to economics because it looks like it's more of a political theory than economics.
Exactly. At its heart, it's not economics. It's maybe a mathematical exercise. People use it for demonstrating something politically, but for describing how events will work in reality, it doesn't apply.
It was used as an example for market failure. Markets are failing, so they couldn't cooperate, and they get each 3 years jail time rather than the 1 year. So it's an example of a market failure usually used to affect market economics. So what you're presenting here is really that you can't use game theory to invalidate or to prove that there is a market failure.
Yes, it doesn't disprove that markets don't fail.
Yeah, that's
I have a question, maybe you can answer it, but it kind of is a reference to Lukash's Professor Dominiak's lecture yesterday regarding what is synthetic, what is contingently true and what is necessarily true. That it seems like empiricism remains in thinking that everything is contingently true, whereas what we're saying is that things aren't necessarily true. We can necessarily know true things about the world. So, how do we get someone who is in this empirical psychology to admit or accept that there are necessarily true statements about the world?
Well, there are regularities in reality. There's some structure that we're studying with science, with physics, with how we move through the world. But what was the word for the empiricist knowledge?
Contingently true.
Contingently
They
true.
say, well, that's because
So
of today.
they're actually right, because all knowledge is contingent. Even if we're studying, we're trying to get what's literally there, what's the necessary truth of reality. Our knowledge, our subjective knowledge of it, is always faulty because we're error prone. Like, for example, like you can take a mathematical statement like 300 something plus 400x, and then you come up with an answer. You would say, oh, it's necessarily the answer I gave, this number, but you could have been mistaken in your calculations, no matter how certain you feel. So all of our knowledge, it is contingent, even though we're trying to study necessary truth. But we just have to go with what's our best explanation of what's going on. But again, it's falsifiable. We can always be disproven by a new theory that comes up.
Interesting. I like it. Thank you.
Is that it? All right, lunch.
Thank you.